Hello YouTube, today I'm going to be showing you the computer science behind the red, green, blue light cycle inside of the Logitech mouse or any gaming mice in general using a Super Starter Kit Arduino project board. So this kit usually goes around 45 bucks on Amazon, and it'll include all of the components that you see here required for this project today. So the components that we're going to be using today is going to be the breadboard. We're going to be using three 220 ohm resistors. Ohms is just the unit of measurement that we use in resistors. I'll explain what these do later. 4 male-to-male jumper wires, our RGB LED, and we have the actual Arduino board. This is basically the brains of our project here today. We also have the USB Type B to USB Type A. The smaller end is the Type A, and this one is Type B. And that's all there is to it for the hardware.
As for the software, we're going to be using the link provided in the description. That will take you to this page. This page will provide you with the software of the RGB cycle project. It is called Arduino IDE. IDE stands for Integrated Development Environment. This is basically, we're just going to be writing code. Depending on if you have Windows, Linux, or Mac. I have Windows. Click it. You don't need to contribute anything. Just download. You'll see something pop up here. Once it's done, click on it, open it, give it a second, hit I agree for the license agreement, and you're just going to hit install. I've already installed it, so see you in the next step. So before we begin, we're going to have to download a specific library. Now, library is basically a set of pre-written codes that are included in a integrated development environment to help optimize our code or our tasks, basically. If you go to the left, we're going to see something called the library manager. Click on that, and what we're going to search for in this would be bridge. Now, I've already got it installed. Make sure it's the latest version, and once you have that installed, we can move on and build a circuit now.
Now, to start it off, this is where we're going to be putting our male-to-male jumper cables, in where it says digital PWM with this approximate sign on it. What PWM means is pulse width modulation. Now, this is a theory. WM, also known as pulse width modulation, is a technique for controlling power. Now, to explain the resistors, whenever there's a piece of technology, such as this one also has resistors in it, but it's slightly smaller. Well, a lot smaller. There's resistance in the keyboards, the mouse, any piece of technology where there's electric current going through it, it is controlled by a resistor. These in specific are in 20 ohms, which means it is not that big of a suppressor. These are basically suppressors. 220 ohms is what this is, and we're using 3 of them. These are not too strong when it comes to controlling the current, but it's enough for today's project. Now, we're going to be plugging in male-to-male jumper cable. Sorry, messed it all up, bruh. And where it has all of the pulse width modulation symbols. So we're going to be using 6, 5, and 3. Alright, now to explain the RGB LED in comparison to a normal LED I've got here. The normal LED has cathode and an anode. You might be asking, dude, what are you talking about? What is that? Well, the cathode is the long leg, the long pin, and the anode is the short one. Now, the cathode is the positive terminal. This is the terminal that will be acquiring or taking in electrons. The anode will just be releasing it. So the electrons are just carrying energy around.
Here is the schematic of the project. This is basically the blueprint of what we're going to be doing, or how we're going to be building this project. On the left here, we have the Arduino board. This is the brain. Remember, the brain of the project. This is what's going to be controlling everything. This is basically the control center. The green lines are the wires. These dots basically mean that the components are connected. These dots right here. The zigzag lines are the resistors. We have it labeled here as 220 ohms. We have 3 of them. These triangle lines with the lines in front of them are as labeled blue, the blue LED. We have the LEDs here labeled blue, green, and red. This line going outwards to ground. This is the cathode. To the side of the cathode, we have the green and the blue LED, or LED pin. On the other side, there's just one red LED pin. So, let's put that together.
So now we're going to pull out the breadboard and start applying our components onto it. We're going to take our RGB light and put it in any row. Doesn't really matter. I'm going to put it in row I. We're going to take our resistors, one of them, or 220, connect it to one of the ends. This is going to be our red. Cathode is right there, the longest piece. Plug that back into the row right there. And you want to make sure this resistor is going all the way through that column for the red pin. So as you can see, it's connected, that's connected, and that's connected. All on the same column. Apply the other 2 resistors, not on the cathode, because the cathode is going directly to ground, but right next to it, to the green pin, sorry. Again, make sure it's the same column. I'll do it in the same row also for neatness. Going all the way through. Blue LED. Same column again. It doesn't matter that these are in the same row as I have here. It just matters that the columns need to line up with each color and the resistor needs to line up with each bins.
We're going to be doing something called declaring and initializing. Now, what this means is that we're just going to be defining the pins. We first declare, which basically means calling it or naming it, just declaring the pin. So we do hashtag define and we call one of them blue. We have declared the blue LED, blue pin. Now we have to initialize it, which means that we're assigning it a value. Or we're assigning it a value or we're assigning it a terminal. This is going to be 3. It's terminal 3, as assigned in the blueprint. We're going to do the same thing. For time efficiency, you guys can copy this and change the rest. So the next one would be green. That's going to be terminal 5. Go down here and change this one to red. This is going to be terminal 6. So we've defined our pins. Next, we're going to do void setup. Now what this does is this is basically a setup. This is a function. This is a method. This has sets of instruction. Now whenever you see these two parentheses by each other, this means that it is a method or a function. Type this out, curly brace, and now this is going to be our body, which is what our steps are going to be. What we're going to write down is pin mode red output, and then semicolon. Now you're gonna want to do this for each color. Green and then blue. What we're doing here is we're taking all of our declared pins, assigning them again by using the function pin mode, and we're saying that they're all output. They're presenting us with an out source. Now this output is going to be basically just them lighting up. That's it. That's their output. Now we're gonna write digital red high. After we've assigned them an out source, basically just turn them on. If we would have said input, it wouldn't have lit up. None of them would have lit up if we were to put input instead of output. Because if we were putting input, that means the LED is expecting something to come in, not expecting to put out something. That makes sense. So red high, blue high, and that'll be the end of our void setup. Now come down, find the variable. These 2 forward slashes are me commenting. Now I'm going to type int. Int is equal to integer, and I'm going to explain in a minute why we're going to be using integer values. Red value. Copy and paste is so goated, bro. I'm gonna go into more detail later on what we're actually doing with these integer values. Now, to assure that we get an actual light cycle from this LED, we have to create a loop. If we were to just leave this, not have a loop in this, the RGB LED would just cycle through one time. It would go red, green, blue, and then it'll either stay on blue or it'll just turn off. The LED would just turn off, depending on how we write the code. Now, if we have a loop, then that cycle will just keep on going and going and going till whenever you want to turn it off. So that is why the loop is important. So what we're going to do here, right, void loop this time. Remember that this is a function. Remember those parentheses. Curly brace after that. Enter. And what we're going to have in our body is we're going to declare and initialize our time loop. So we're going to write hashtag define, and the keyword we're going to use for our time loop is delay time. And we're going to go for 10 seconds. And so this, add a comment here, this is our light cycle or our fade in between colors. Now, what the integer is, we're going to have a integer of values 0 through 255. Now, what this is, regarding LEDs only, 0 to 255 integer value are the brightness levels of the LED. As we can actually code our brightness. And so for this void loop method, we're going to be using something called a for loop. A for loop is going to be a loop function with the instructions in the parentheses, not in the curly braces, in the parentheses. How this works is we declare and initialize a variable integer, int, and I declared a new variable int, just like this up here. See how it highlights? Now we initialize it. We're going to set this to 0. Why? You'll see in a second. We're going to type a semicolon, go on to the next set of instructions. We're going to go I is less than 255. This is the integer value that we don't want to go above, because that's the maximum brightness level for the LEDs. Another semicolon, and the last piece of instruction is going to be I plus equals to 1. What this does is it iterates through every single integer value. from 0 to 255. So it goes 1, 2, 3, all the way to 255. Why we selected int I as 0 initially is because it is 0 up here. We have to initialize a new int in a for loop to 0. That is the first default set of instructions for for loops. Another curly brace right to the side of the set of instructions. Before we even move on, we're going to just initialize these integers up here. How we're going to do this light cycle is that we're going to start with turning on the red light part of the LED. Initialize this to the maximum brightness. We're going to go blue value, set that to 0, the lowest brightness, to 0 as well. So we're going to start off by turning on the red LED. Now back to inside of the for loop, here we go. We're going to set red value as a decrement. So instead of going plus equals to 1, we go minus equals to 1. Then we're going to go green value is going to iterate 1. Now what we're doing right here, you see how we're decrementing it by 1 for red value? Since the red light on the LED is turned all the way up to 255, we're going to slowly fade that down and slowly turn on the green light at the same time. That's what we're doing here. Now after this, you'll see this in motion once we're all done. We're going to write a new thing called analog write. We're going to write RED red value. This is basically connecting this data with this data. Semicolon after that, analog write again. Now this time, it's green's turn. Green value. Make sure that you're spelling everything correctly, even including capitalizations. Syntax is pretty important when it comes to coding. And we do not want to forget the delay time. Otherwise, it'll be a weird looking cycle. It won't be looking as smooth. We're going to have our delay time, which is 1,000 milliseconds. Alright, now, we're almost done. What we need to do is literally copy and paste this under the second to last curly brace, paste, and change it up for the other ones. Now it's blue's turn to be maximum brightness. I'm sorry, green's turn, 255. Because green is up next. From this is up next. Or from this first set of data, red is going to be the one that's maximum brightness, and then it's slowly going to go to green as red fades away. That's why this is going to be set to 255. Now, we change this. Go down here. Now the green value is fading out. And guess where it's going? Guess where the next light is? That's fucking right, blue! And what do we do here? Get rid of this. Type in green. There you go. Green value. And oh, what's this? Blue. Change that to blue value. Now you see what happened here, right? Red is slowly fading away, going to green, slowly turning up the brightness. Now this green is basically a braking function. Now once green has reached 255, it's now time for it to slowly fade out. Now, what we do here, we just grab this, copy, and paste it again. Last thing, this is 0. 255, that's right, big blue. Who's slowly fading out now? That's right, big blue. Who's going back up again? This is a cycle, remember. This is going infinitely cycle. There you go, red. Just remove this, make it easier for us. Enter here, take this whole thing right here, copy, boom, paste it. And there you have it. That's it. That's all there is to it. And then from here, we verify our code. This checkmark button, no errors. It'll show us how much storage this took, this code. And on to the next step.
From here, we're going to take our USB cable, take it to any power source. I've got to connect it to my PC and then plug it into this USB type A port right here. Alright, and we're going to go up here and click upload and then watch it go to work. There you have it. Yeah, the light cycle using the Arduino board.